Use the right pyramid to answer the following questions. We're going to look at question 5 together. How many edges are there? There's 1, 2, 3, 4, 5, 6, 7, 8 edges. Remember, the vertices are the points where the faces connect. So these would be the vertices of the shape. Lateral faces go around the center of them or the middle of the shape. Bases would be the top and bottom. So go through and finish those questions for your warm-up. This is a digital lesson, so if you have access to it, go ahead and follow along there, or just watch the video as you go through and take notes in your workbook. So it asks us to try and find a cross-section that is a face of the cube. So when we line up perfectly with the face, or we could rotate and get a face on the side or on the front, and shift it forward or backwards. So you can see that it lines up there. Find a cross section that is not a face of the cube but is identical to the face. Well, if we look here, from the top view, it's identical to the top, but it is not a face. Find a cross section that is a point. Get as close as you can. So I'm going to rotate and shift it. You can see that as we shift farther and farther out, we would get closer to one of these corners. But it says get as close as you can, and since it won't let us shift our plane any further, that's as far as we can go. What strategy did you use to find a cross-section that was a point? I cut at an angle and shifted the plane as far out towards the corner of the solid. Find a cross-section that is a line segment. Get as close as you can. So we're going to line it up so that it matches up with one of the sides. Let's see. And then we'll shift it out towards. And if we keep shifting it outwards, you can see it's going to get closer and closer to that bottom section. How is finding a cross section that was a line segment similar to finding one that was a point? And how is it different? we had to use a plane that was angled for both, but we wanted to go through one plane to create a line segment and no, I guess I should say one face, not plane. Faces to get a point. Find a cross-section that is a rectangle but not a square. If I angle the plane in one direction, that would create a rectangle. If I line it up to match the face to be perpendicular or parallel to one of these faces, it would be a square. So I need to angle it to create a rectangle. Now find a quadrilateral that is not a rectangle. So we'll need to angle it in multiple directions. Here you can see I have a parallelogram. It's slightly angled off to the side. Find a cross section that is a triangle. So we're going to angle the plane and then we're going to also scoot it out towards the corner. So we get a cross section that is a triangle. Can you find a cross section that is a pentagon? So it needs 5 sides. Here I have 1, 2, 3, 4, 5, 6. Let's see if I scoot it out towards the edge. Again, I have 1, 2, 3, 4, 5, 6. So if I angle it, I'm able to create a pentagon. One, two, three, 4, 5, 6. Let's see if I shift it out. 1, 2, 3, 4, 5. So that creates that pentagon. Can you find a cross section that is a hexagon? Here's 1, 2, 3, 4, 5, 6. And as you can see, there's multiple hexagons that we could create. 1, 2, 3, 4, 5, 6. Can you find one that is an octagon that has 8 sides? So if we adjust at any angle, think about the number of faces on our solid. The maximum we could get is 6 because there are only 6 faces on a cube. So we'd have 1, 2, 3, 4, and then 5, 6 for the top and the bottom. So creating an octagon, there are only 6 faces, so the most we would get would be a hexagon. We won't be able to create an octagon because there are not 8 faces in this 3D solid. Find a cross section that is a triangle. If we cut one that is perpendicular to the base, we will get a triangle. And if we shift it out, it will change. but we want to cut straight through the center, or we could try and cut through the side and slide it out towards the corner to create a triangle as well. Find a cross-section that is a trapezoid. A trapezoid has one set of parallel lines. So there is a trapezoid. The top and the bottom are parallel. You may also be able to rotate to find another trapezoid. There's another one where the top and the bottom are parallel. A trapezoid also has 4 sides, so it needs 4 sides and one set of parallel lines. Find a cross-section that is a kite. Let's see if we angle our pieces to try and get a kite-like shape. There's a kite-like shape. Cutting diagonally through the upper section. Find a cross-section that is a pentagon, so it needs 5 sides. Here's 1, 2, 3, 4, 5. Find a cross-section that is a hexagon. This one has 1, 2, 3, 4, 5. Well, let's think about our pyramid. The pyramid has 1, 2, 3, 4 lateral faces and 1 base. So the maximum we can get here would be a pentagon with 5 sides. A hexagon requires 6 faces. When making cross sections with the cube, do you think it is possible to make an octagon? No, we were not able to create a cross section that was an octagon. When making cross sections with the right square pyramid, do you think it is possible to make a hexagon? We also couldn't make a hexagon from the pyramid. And then the reason is because the maximum number of faces in that pyramid was 5. So we could only make a pentagon or a cross section with fewer sides. So 5 or less sides from the pyramid, because it had 5 faces, and 6 or less sides from the cube, because it only has 6 faces. Now explore. You can play around with how many sides are on the base. You can adjust it to be a pyramid or a prism. And you can adjust how big or small the prism or pyramid is. And you can try and see what happens when you adjust the angle of your slice, and how many sides you can get based on where you slice your shape. What would happen if you added more sides or fewer sides? What would happen if you changed it from a pyramid to a prism? What types of shapes can you get? This is just an opportunity for you to explore different prisms and pyramids and different cross sections. And then that is the end of this lesson. You can check back for future lessons on my YouTube channel.